Hello, we are continuing our series in geometrical shapes, finding out the interior angles and further on. In this particular video, what we are going to do is that we are going to find out some of the features and properties, including some of the interior angles of different shapes, geometrical shapes. Now you see I have written pentagon and other geometrical shapes. So I have drawn here triangle, a square, a pentagon and a hexagon. So this contains 3 sides, 4, 5, 6 and it can be further 7, 8 and so on. Now let us see that how we can find out the interior angles of those shapes. Now we know there is a common formula through which we can find it easily. And this formula states something like this: n minus 2 multiplied by 180 degrees. Right, whereas n equals to the number of sides. This is a standard formula. So now let us see that how we can apply it with a triangle. So triangle, we know that the number of sides are 3. So we can take this as 3 and we can find it out as 3 minus 2 multiplied by 180 degrees, which brings to 180 degrees. And we can find that the sum of the angles of this triangle would be 180 degrees. Let us find it for the square. We know that there are 4 sides, so let us take n equals to 4 and we will find it 4 minus 2 multiplied by 180 degrees, and it would be equal to 2 multiplied by 180 degrees. It would be equal to 360 degrees. In general, we know that the squares, all the sides are right angled, so we can just put it up like this. 90 multiplied by 4, we can find it out as 360 degrees. Let us find it out for pentagon. Now we know pentagon means number of sides are 5. So we can put it as 5 minus 2 multiplied by 180 degrees. It would be 3 multiplied by 180 degrees. It would be 540 degrees. Let us find it for hexagon. So how many sides we have? 1, 2, 3, 4, 5 and 6. This is a regular hexagon. So let us see what it can be. N equals to 6. So we find it as 6 minus 2 multiplied by 180 degrees equals to 4 multiplied by 180 degrees gives us 720 degrees. So you see that if we can substitute the sides, number of sides, this is a very good formula and we can find out this the total angles for triangle, square, pentagon and hexagon. Now there is another way in which we can find out the sum of the interior angles of a pentagon. So we will consider the value or the geometrical shape of pentagon right at this moment. So for a pentagon, let us draw the pentagon, this one once more, and then we can find it out. So let me draw it over here. It has got 5 sides, so it would look something like 1 and 2 and 3, and we get here 4 and 5. Yeah. So this is a pentagon, and let us quickly rename those sides. We name it as A and B and C and D onwards. So this is A, this is B, this is C, this is D and this is E. Now see, we can definitely find out as the number of sides are 4 by this, but we are looking for something different. So let us drop a kind of a perpendicular over this, right? So what we get when we draw this line, now this becomes a triangle, right? So let us see what are the angles that this triangle CDE comprises of. So what we will do is that we will write over here the triangle CDE. Oops, I'm so sorry. Yeah. So triangle CDE would be comprising of angles DCE, this is DCE, this angle, plus DEC, this angle, plus angle D. I am writing this angle D separately. You will soon understand the reason. So this actually comprises of this triangle. Now when we have dropped this this bisector, obviously this let us say EABC has become a parallelogram. So in this case what we can do is that we can write that ABCE, let us go this way, yeah, fine. So this parallelogram ABCE, right, equals to what? Now we have one angle, this let me use a different color so it would be easier for you. One angle, we have this one, right? This is angle A. So we have angle A. We have another angle, angle B plus, so we write it as angle B. Then we have angle BCE, which is the angle C. I will soon tell you why we are writing BCE and not C. And we have angle AEC, that is this angle AEC, this plus angle AEC, right? This would be equal to 180 degrees because this is a triangle. This would be equal to 540 degrees because this is a parallelogram. And we have seen that this would be equals to 360 degrees. I'm so sorry. This would be equal to 360 degrees, right? Yeah, because it's a parallelogram and we have seen this. Parallelogram is 360 degrees, right? So this would be 360 degrees. Now if we equate the left hand side and right hand side, so we can always write by using formula of algebra, we can always write over here that LHS plus RHS, what does it equal to? We have angle A, so we write angle A. Then we have what? Angle B, so we are going in this way, so we write it as angle B. Next what we have got, we have angle C. But just note one thing, angle C, which we have over here, is a sum of angle BCE, this one, BCE, and it is also a summation of angle DCE, right? And this is the entire big triangle, big angle. So it is a common angle which shares both the parallelogram and the triangle. So let me write it in this way. I put a bracket over here so it becomes clearer for you. So let me put a bracket over here and let us write angle BCE plus angle DCE, this angle DCE, which actually is the angle C. So we write it as angle C. So this plus corresponds to this. And we have this angle D, which we already have. Now we have another angle which is E. Just note one thing, this angle E is actually a summation of angle AEC, this one, right? Plus the summation of DEC, this one. So this is the big angle. So we can write it in this way. We can write angle E plus angle E, we will write it, but we can write plus, yeah, this is much clearer, yeah. So it would be plus, and let me write angle AEC plus angle DEC, right? So yeah, so angle DEC, right? And this is the angle E. So now we get angle A plus B plus C plus D plus E, right? So now let us write it. So, and this one would be equals to how much? 360 degrees we have already written. So we will write over here equals to angle A plus angle B plus angle C plus angle D plus angle E. So all of them would be equal. And how much it would result to? This would be equal to 360 degrees plus 180 degrees, and this is equal to 540 degrees. And that is basically the sum of the angles of a pentagon. And we have seen here by formula we can find this one. So the basic objective of this is that by using formula as well as by internally constructing the angles or dropping the bisector and making a summation of that, we can also arrive at the same formula. So this was the basic intention of this. Now I have to show another thing. So for example, let us say for example, we are taking abruptly 2-3 figures. Okay, say for example, we take one figure for convenience. Yeah, we are taking a right angle triangle. Yeah, we can take a right angle triangle. So for example, an equilateral triangle, for example, this one, and I take a parallelogram, right? I take a parallelogram over here. Now, say for example, why we are using a, and let us do another thing. Let us do another exercise. We take a pentagon too, right? We take a pentagon. So 1, 2, 3, 4, and 5. This is an irregular pentagon due to my drawing, so it doesn't matter. So now what we see for example, if this is the triangle and we name it as ABC, right? We know the internal angles of the triangle is always 180 degrees, right? So this will be 180 degrees. Now for example, this is a, say for example, it's a parallelogram and we can call it as ABCD, right? Now, say for example, I am not considering the angles by the n-2 multiplied by 180 formulas, whereas I draw a bisector. So this becomes a triangle, this becomes a triangle. So automatically these two triangles, this triangle, say ADC, say triangle ADC plus the triangle, say for example ABC, it would eventually be always equal to 360 degrees, isn't it? Because the sum of the triangles, by theorem we know that. Now for example, we take this pentagon. Earlier also what we have done, we have dropped a bisector. We make this 360 because it is a parallelogram. This we make it as 180 and automatically this comes to 540 degrees, right? Now for example, say for example, what I do over here is that I am taking for example a hexagon, pentagon and then a hexagon, for example. So what it eventually leads to, say for example, I draw it 1 and 2 and 3 and 4 and 5 and 6. This is a nice little hexagon, right? Now we know by n-2 formula, again we can calculate. But for example, what we are doing over here is that we are drawing again few bisectors. So let me drop over here. Let me drop over here. So again what is happening? This is again 180 degrees. This is again 180 degrees. 360 plus this is a parallelogram. So internally it would be 360 degrees. This is a hexagon. So it has six sides. This is a pentagon. So you see now what it would be. 360 degrees plus 360 degrees. It would eventually lead to 720 degrees. I hope you can see this one. Right? Now, why I did this exercise? Because you see that other than the formula, if we are constructing and dropping bisectors in between, then this whole idea of doing is that we are always trying to find out triangles in between. See this triangle, this is a triangle, these are the two triangles. Right? So we are always trying to find triangles so that it becomes easier for us to find the analysis, summation and so on. Taking this forward, let me show you another example. See for example, we here again let us draw a pentagon of 5 sides, right? So here I am drawing a pentagon. So here what I do is that let me draw a pentagon which looks something like this. So we have here and this one and this one, 2, 3, 4 and 5. So this is some kind of a pentagon, say for example. So it has got how many sides? 1, 2, 3, 1, 2, 3, 4. This is a hexagon. This is a hexagon. So for a pentagon, it would be something like this. It would be like this. Five sides, right? So we get a pentagon. So this is a pentagon. This is a hexagon. 1, 2, 3, 4, 5, 6. So with this pentagon, now for example, I want to find out, say for example, the number of triangles that can be formed. Non-overlapping triangles, right? So what I do is that I drop a perpendicular, or I do a bisector from here to here, and I drop another from here to here. Mind it is not a straight line because of my horrible drawing, but anyway it seems to be quite okay. So how many triangles I have got? 1, 2 and 3, right? And what is the summation? It would be 180 multiplied by 3 equals to 540 degrees, which is the sum of the interior angles of a pentagon. Now if I draw something like this, it would be similar kind of a thing with this. If we draw this one and this one, this would be one triangle, this would be one triangle, and this would be a parallelogram. So in this way we can derive. So this is, see, you can draw, we have got 3 non-overlapping triangles, clear? Now if I get something like this, for example 1 and 2 and 3 and 4, it looks like a sigma although, but I'm not considering this to be a sigma. Let us say we have got 4 sides, right? 1, this is the first one, and 2 and 3 and 4, right? And I drop again, so we get, see, this one up to this. So we get 1 triangle and we get 2 triangles. So with 4 sides, let me write it for you, it becomes easier so that you can understand what I'm trying to show you. With 4 sides, we get 2 triangles. If this is so, then the number of triangle, obviously it will be equal to 2 plus, say for example, side I represent it as n minus 4, which is already given. I deduct it, and what I get is n minus 2. And this is exactly what we have done over here. You see, n minus 2 multiplied by 180 degrees. And this is exactly what I was trying to show you over here. That with the pentagon, which has got 5 sides, and if we are dropping in between the lines, we get triangle. And with this 4 sides, if I get with 4 sides 2 triangles, so it would also lead to n minus 2. What eventually is the result of that? That means for a polygon which has got n sides, say for example, we have got a polygon, say for example a polygon given, it would be something like given a polygon where n equals to say for example I have got 50, for example. That means the number of sides are 50. That means if a polygon is given the number of size 50, that means I can always write number of triangles will always be equal to n minus 2, that equals to 50 minus 2, that means 48 triangles. So with 50 polygon we are getting 48 triangles. So how many angles we will get? The value of the angles will be 48 multiplied by 180 degrees. It would be 8640 degrees. It would be 8640 degrees. That means similarly, given a polygon, I represent it as P, given a polygon which has got 102 sides, that means n equals to 102, the number of triangles it would be forming would be 102 minus 2 from this particular formula, and it would be 100 triangles of a 102 sided polygon, and the number of angles would be 100 multiplied by 180 degrees, it would always be equal to 180 and then further 2 zeros. So this would be 180, 180, then 1 and 2. So this would be the number of degrees. That means it is almost 18,000 degrees. So this actually brings to the end of our video. Let me just quickly recap what has been the motive and what I tried to show you. We started with different shapes, geometrical shapes, and with the formula of n-2, we have shown that how we can find out the total number of angles of a triangle, square, pentagon and hexagon. Considering that, what we have also shown is that by making a geometrical figure or dropping bisectors, we can also find out that the sum of the interior angles of a pentagon would be 540 degrees. And similarly, we have also shown that if we don't use the formula, geometrically, how we can find out the different triangles that are lying in between the shapes of a parallelogram, pentagon and hexagon, and that is how we find the values. Considering a hexagon as well as a pentagon, what we have also found out that in this way we can find out the number of triangles. Given 4 sides, we can find out 2. So this value, formula n-2, actually shows the number of sides given for a polygon. I won't say polygon, it would be for anything. We are considering polygon right at this moment. So for 50, it would be 48 triangles multiplied by 180 degrees. It would give you the total number of angles, value of the angles. Similarly, if we consider n equals to 102, we will also find out the total number of triangles multiplied by 180 would give us the value in terms of angles. So this was a video which I intended to show you. This would clear up the concepts related to angles, triangles, and also concepts which are very important in terms of different geometrical shapes and how these geometrical shapes can be done both in terms of formula and in terms of dropping perpendiculars and bisectors getting the same value. I hope that you learned something new and you enjoyed this video. I hope you're staying safe and fine, and continue watching the series of geometrics videos that I will be coming up with more interesting notes and more interesting videos which will carry on in this series. Thank you very much for watching the video.